Hello friends, welcome to all of you on JEE Physics Maniac. So today also I have come up with another question regarding the springs, and this will be the last series of the springs, and after discussing this question I will show you two questions for you to work out, right? So without wasting much time, let us proceed. So here the statement of the question is saying the system is at rest with the spring unstretched when theta equal to 0. This is the angle theta, you can clearly see. And they're saying 3 kg particle is then given a slight nudge to the right. If the system comes to the momentary rest at 3 equal to 45 degree, determine the spring constant K. And for the value of K equal to 100 Newton per meter, find the speed of the particle when theta equal to 37 degree. Use the value B equal to 0.4 meter throughout and neglect friction. So I am not going to do the entire calculation. I will be leaving the calculation part up to you. I will just discuss the crux fundamental part of the question. Now here you can see that when the bob is in this position, I am assuming that from this topmost position of here, this decrement in length is delta H, and I can assume that this is Y, correct, with the pulley, and this length that you are seeing over here, because when the system was at rest at theta equal to 0 degree, this entire length was Y only. And there is an extension in the spring that I am taking to be delta X. So this portion, this length has become Y plus delta X, correct? It is very simple. So from the geometry delta H equal to, we can write B into 1 minus cos theta. As you can see, this entire thing is B. This is B, and this much is B cos theta. So delta H becomes B into 1 minus cos theta. It's a very simple thing. So there is no need to discuss it in detail. Very elementary and rudimentary thing, right? And delta X equal to, what can I write? Delta X is equal to length of this portion AB. This length of this portion AB minus Y. This was the initial length. Okay. So that was the extension of the spring. So that we'll get from there. And Y, obviously this length is nothing but, total length is 1.25 B and this entire is B. So from there we can get that Y is equal to 1.25 B minus B, that is 0.25 B. Now, so if I come back to this calculation of length of AB. Length of AB is what basically? You can see this right angle triangle over here. This is the right angle triangle, and it is very easy to calculate from there, because this is length of AB that I'm talking about, correct? And if we think about this particular segment length, this is nothing but B sine theta. All right, this is B sine theta, and the other part that is this entire thing, that Y minus of this segment we will get, that is 1.25 B minus of B cos theta. Okay. See, you can see this is B cos theta. This entire thing is B cos theta, right? And this entire is 1.25 B. So this length becomes 1.25 B minus B cos theta. I think there is no harm to understand this part. Very simple thing. So now if I apply work energy theorem, work done by the spring plus work done by the gravity, since it is coming to momentary rest at theta equal to 37 degree, so 45 degree, I'm sorry, theta equal to 45 degree. So changing kinetic energy will be equal to 0. So if changing kinetic energy is 0, then spring from relaxed position to extended length, negative work done minus half K delta X square, plus coming down, so work done by gravity is positive, that is mg into delta H is equal to 0. So after doing the calculation, we will get the value of K. Simple thing. There is no doubt at all. And for the second part of the question, we are again applying the work energy theorem. We are writing work done by the spring plus work done by the gravity is equal to change in kinetic energy. Now here in this case, when theta equal to 37 degree, the system is not at rest, so it will have some kind of velocity. So for that, we will do the same calculation. Half K into delta X prime square will calculate the extension of the spring as we have calculated in the previous case. Mg into delta H prime, in the similar way we will calculate, that will be equal to half mv square minus 0, and from there we can get the value of V. So it's a simple thing. This question is fit enough to come for single option correct. I mean, the majority part of the question is not involving much concept, but calculation wise little bit tedious. For that you have to be a little bit careful in the exam hall. So that's all. Now in the next video, I am going to come up with a very interesting thing. The concept on which question came on ITJ 2016, that is on Coriolis force, and I will be discussing the entire fundamental part of that particular topic. With that, I will discuss 3 questions, so that will be real beneficial for you. So stay tuned, and thanks again for being patient with me, for supporting the channel. I need more support from you people. Help me to reach out to 1000 subscribers. Please do like, subscribe and share. And at last, I will show the 2 questions that I ask you people to solve. Okay, so you can take the screenshot. So this is one of the question. I will just hold for a couple of seconds. You can take the screenshot and you can try on your own, and do let me your answer in the comment box. This is one. And the other question is that I will also hold on here for a couple of seconds. Yeah. So out of the 2 questions I have shown, my personal choice is this is bit important regarding your JEE advanced preparation. So work this out and do let me know your answer in the comment box. Thanks again. Thank you.